So here's a couple more examples. This time, I'm just asking you limit as x approaches infinity, left limit as x approaches negative infinity, 5x fourth minus 27 over 3x squared plus 4. The next one is 3x squared over 2x plus 7, limit as x approaches infinity, limit as x approaches negative infinity. And then x cubed minus 27 over 3x plus 5, limit as x approaches infinity, limit as x approaches negative infinity. What do you think they are? Pause the video and prepare your opinion. Okay, coming back, hopefully you've worked that out. And so I picked these examples because they illustrate what I mean by, if I flip back to these notes, what we mean by when the degree of the numerator is higher, the limit as x approaches positive or negative infinity will be positive or negative infinity depending on what happens to a large number in there. Okay, so you just want to think about the signs of the leading terms. So what a lot of these limits really come down to is the leading terms, the higher exponents, is we're going to control where this function goes as the x gets larger. Even if x gets up to 1,000,000, this 27 isn't going to do anything, right? It's going to be the 1,000,000 to the fourth power up here that's going to be really controlling the function, all right? But also this 3x squared down here is going to control the denominator of the function. So what we have to do when we're looking at limit as x approaches infinity, okay? So first of all, we're going to notice that the degree of the top is higher. This is the case on all three of these. The degree of the numerator is higher. So we know we're going to have plus or minus infinity, and the only point of this video here is how do I know whether I have positive infinity or negative infinity, all right? So what you do is think about what if I had large numbers for x fourth and x squared. So basically just look at your leading terms. Then I'm going to have, so x fourth is going to be positive, x squared is going to be positive, 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 everything's positive. So as we go to positive infinity, that limit's going to be infinity. But what about when I go to negative infinity? So when you go to negative infinity, again, we're going to really look at these leading terms as controlling the entire function as x approaches negative infinity. So when I do a negative large number to the fourth power, I'm going to get a negative number. I'm going to get a positive number. And a squared is also going to be a positive. So even when I go to negative infinity, I'm still getting positive numbers top and bottom. So this is going to go to positive infinity. You know, maybe we'll take a quick look at that function. I don't know if that's worth doing. Maybe I'll pop it up for the next video. Then the next one, I have 3x squared. So I have my highest exponent in the numerator. What's the limit as x approaches infinity? Well, if I look at my leading terms, okay, as x approaches positive infinity, I'm going to have positive in the numerator, positive in the denominator. It's going to be positive infinity. But when x approaches negative infinity, okay, what's going on? The numerator is going to be positive because I have x squared. Okay, but the denominator is going to be negative. So I'm going to have a positive divided by a negative. I mean, think of what would happen if I put, negative 100 in here. In my numerator, I'd have 30,000. In my denominator, I'd have negative 193. So it's going to be a negative number. And it's going to be an increasingly large negative number. So it's going to negative infinity, basically, because if I put a negative top and bottom in these leading terms, I'm going to have a positive over a negative, which is a negative. So in the first case, you go to positive infinity whichever direction you go. In the second case, you get positive infinity if I go to the right and negative infinity if I go to the left. All right, so what about this one? X cubed over 27. What do you think is going to happen in terms of the signs? Well, as I go to positive infinity, I'm going to have a positive number. So just looking at the leading terms, this will be positive, this will be positive. So I'm going to go to positive infinity. And as I go to negative infinity, so when I have a negative large number and I cube it, third power, it's still going to be negative. And if I have a large negative number here, it's going to be 3 times the negative number. It's going to be negative. Negative over negative is positive, so this one's going to positive infinity. So these are examples of what happens when I have limits at infinity that are going to either positive or negative infinity. In other words, the case where, when you learned about horizontal asymptotes, you learned that if the degree is higher in the numerator, then there is no horizontal asymptote. But there is a limit. There are limits as you go to positive infinity or negative infinity. And they might both be positive infinity. They might one be positive infinity, one be negative infinity. These could be switched. You just have to think about what happens when I put a large positive number or a large negative number into this expression.